my favorite
I know.
kind. But yes, sir. So Welcome to the 2025 TARC Scientific Symposium. Please welcome the Scientific Director of the Texas Alzheimer's Research and Care Consortium, Dr. Monroe Cullum, from UT Southwestern Medical School.
Good afternoon, everybody. Hopefully everybody can hear me. It is my distinct pleasure today to be able to introduce our keynote speaker. But first, we have to thank our keynote speaker for stepping in. As many of you who looked at the program before yesterday, you saw an NIH leader on the docket to speak. And as of yesterday, the NIH they're not allowing them to travel, so he had to cancel abruptly. But we have really good news because we have a similarly distinguished speaker who has a long history with TARC, actually. I'm pleased and proud to introduce Dr. Stephen Waring. Dr. Waring is actually, he's a vet. Some of you are thinking veteran. Some of you are thinking veterinarian. A veteran of TARC? What am I talking about? All of the above, actually. All of the above. He got his DVM from Texas A&M and his PhD in epidemiology from UT Health Science Center and the School of Public Health in Houston. And he is a native Texan, so that's another advantage we have. He is a researcher, a teacher, and a very popular speaker. He is a principal scientist at Essentia Institute of Rural Health and an adjunct professor at the University of Minnesota. By way of history, Dr. Waring was one of the founding members, if you will, of TARC back in the day, and actually served as an interim director of TARC for a while. And I watched and admired his ability to work with a variety of personalities and different challenges over the years, and he really did a great job with his leadership there. He is a PI or co-PI on multiple federally funded grants. He's got well over 100 publications. He's well known in the field of neurodegeneration. He's an expert in not only epidemiology, but in data science, precision medicine. He's written and spoke on the use of AI, pharmacogenetics, digital health and aging, and especially rural health. And he is widely known for his work in the areas of aging and dementia. And plus, we got to give him an extra big Texas thanks for coming back to Texas to give us this talk, but mainly for stepping in and agreeing to do a keynote address with less than 24 hours notice. So without further ado, Dr. Waring.
So it is a distinct pleasure, honor to be here among you. Really, as Dr. Cullum said, I was at the beginning. We did a lot of work to put this thing together with certainly some high expectations and definitely expectations of, well, if we're going to go to all this work and get all this money, it needs to be sustained. And the true metric that we need to look at measuring our success is how well are we supporting new scientists coming into the field, because that's what drives us. And our mentorship, that's our job. And I'm just really proud to see this thing, this many years later, exceed all expectations. So you should give yourself a round of applause and congratulations for just being here. So I'm kind of the pinch hitter, and clearly I'm not the director of NINCDS, and I think we were all looking forward to hearing that perspective, because we know the more we know about Alzheimer's, the more we don't know about Alzheimer's. And we learn stuff from cancer. We learn stuff from many other fields, and we begin to see the overlaps of biological pathways and trajectories and things. that sometimes we learn something from a different area, Parkinson's or ALS or whatever, and we know that may very well apply as well. So what I did was I put together a talk that I thought would be originally it was going to be the last talk, and kind of that more thought-provoking, more like, we all know about AI, we know about digital health, we know about the roles that could play with, improving precision medicine. But we were going to have a short talk, and then yesterday when I found out I was asked to do this, I decided not to expand my slides. I'm from Texas. I have the gift of gab. When somebody says, can you stretch it? Of course I can. But I do want to give some time at the end for your thoughts, because we all are in this together, and we all have some incredible ideas, experiences, maybe new ideas that we haven't even thought of before. So basically, I'm going to talk about prevention. I'm an epidemiologist. I'd be remiss if I didn't talk about that. Certainly the AI piece, digital health, and then this thing that I like to call precision prevention. And what do we mean by precision medicine? We got over 400 people in here. We're going to get 400 different definitions of that. Some of the things be common, but we all have a different idea of what that really is, which is good. I think the heterogeneity amongst us is a true strength. If we all thought the same way, we wouldn't get very far. So when we talk about prevention, I think of it in terms of how do we preserve vitality? How do we preserve independence? Because when you talk to elderly patients, even if they don't have a dementia or a cognitive impairment, this is their biggest fear. That's going to come along and rob them of their independence. They won't be able to drive. They won't, all of these things. So really, anything we can do that preserves that vitality, cognitive vitality as well as physical, and that independence is definitely, I think that's why we're all here. It's worth pursuing, leaving no stone unturned. We also talk about prevention in terms of just delaying onset. So that prevention by delay effect, that's not trivial. I'll show you a slide here in a little bit and kind of what that means. And along that line, we also think of changing trajectories. And so the trajectory can be anything. It can be cognitive. It can be institutionalization. It can be death. It can be whatever the outcome is. The more you can push it out, in the interest of quality of life, not quantity of life, that's really where the sweet spot is for what we need to be looking at when we talk about precision prevention. We know there are multiple risk factors. As an epidemiologist, that is job security for us. This is every week there's something new to put in that equation. And maybe a couple of things if we're lucky to take out of the equation because there's already too many things. And then I'm going to talk about component causal mechanisms just briefly. And that's just one way that we, from epidemiology, we define causality. There are other ways, but that's the one that's near and dear to me. So when we think of that support, where's the evidence that says this really can't happen? Well, we already know enough to know what's good for the heart's good for the head. That's a little ambiguous, I get it, but it really is. We're learning more and more that certainly from the finger study, you're all familiar with that, the Finland group, and others that have looked into this, it's not just this overall benefit of lifestyle interventions. And for the finger study, the lifestyle intervention was a combination of diet, exercise, cognitive exercise, networking, social networking, and all the things that we know are important to continue to maintain cognitive vitality and function. So when you look at all of that, compared to a group that was not subjected to all of that, pretty impressive, pretty compelling evidence that there's something there. Even if we can't put our finger on exactly which marker it is or exactly what it is, there still is something there. So that's the low-hanging fruit. So then we begin to think of, well, does that apply to everybody or is that just certain people? How do we profile people in a way that we're saying, okay, you would benefit from this kind of an intervention? Because it's not one size fits all. We know that. That's that's what precision medicine's all about, trying to get away from one size fits all. And our patients expect us to do that. They know more and more about precision medicine, thanks to Google Doctor, Dr. Google or whatever, which is good. Keeps us honest, keeps us ahead, and certainly takes away our ability to just blow smoke. Unlike, I'm not going to get into that. Never mind. So the other thing that's interesting is, like, biologically, what's happening when we say exercise and diet and looking at sleep profiles and, you know, the microbiome, the gut health, all of these things have some influence on what we know is happening neuropathologically with Alzheimer's. So you're going to have all of these slides. Use them, lose them, whatever. But I do want you to, if you're interested, all of these are fairly recent publications. So there's mounting evidence out there. And the more we take that and say, well, let's test this over in this group, in this population, we begin to see that these things are holding pretty true. The magnitude of effect, sure, might be different, but still there's something to it, certainly worth pursuing. So this concept of sufficient component causal models, I embraced that during my PhD program. We were introduced to all kinds of, propensity scoring and certainly the counterfactual methods, all sorts of ways to establish causality. What I embraced while I was going through my PhD program, I was also minoring in neuroscience and kind of getting into both Rett syndrome, that earlier neurodevelopmental stuff, and working with Huda Zogby and others, but also kind of getting into the older end, the Alzheimer's and things like that. And I realized that for both of those ends of the spectrum, when you got into neurodegenerative and neurodevelopmental, that puzzle that you're trying to put together has many, many, many pieces. And when you get that puzzle put together, if you're lucky, it might only apply to 1 or 2 or 3% of the people. So again, that's why I think these thinking of it in terms of component causal models, each component being a piece of that puzzle. The puzzle is multidimensional, and it's kind of like if you like puzzles, it's like your puzzle nightmare. You bought a puzzle that has 1,000 pieces, but as you're putting it together, these pieces clone themselves, and it becomes an unlimited number of pieces that you need to figure out, well, where does that one go? So that kind of is the journey. I know I'm preaching to the choir here. So again, I wonder if this would work. Oh, shoot. Sorry, my bad. Yeah, there you go. So we begin to think of these markers or things that would be fitting into either, the biomarkers and the MRI changes and all those things going on in the brain, the physical attributes, and then certainly the psychosocial. So if we measured all these things and have a discrete, very well-defined way of categorizing individuals, it may very well be that for some group, only 4 of those things turn out to be important in terms of explaining why they developed Alzheimer's. For others, there may be some common pieces, but there may be new pieces. We already know that, so that's not new news. I definitely. So the key to this, though, is each piece of this puzzle, if we get it down to, for some groups, if you could just measure these things and their modifiable risk factors, then you're going to really know and have this expectation that if we can get to those risk factors early enough, we can change this trajectory. That's prevention. Prevention by delay, call it what you want. I'll take it any day, because if you look at those figures, sorry, you're not looking here, you're looking there. So if you look at these figures, here in the great state of Texas, this is a publication that came out in the Alzheimer's Facts and Figures 2024, estimating that in Texas there's right at 460,000 folks that have AD. This is applying estimates. These are reliable estimates. Did we go out and count these noses and we know we have that many? No, of course not. But you know how we do this. But whatever the number is, if you said, what about a 1% reduction? What if we came up with something that if we intervened on that early enough, every year 1% less would come down with Alzheimer's? That's a pretty impressive figure. That's not trivial by any means. And so you can change trajectories anyway, and there's evidence where when you do cognitive interventions and other things, when you layer something onto a pathway, a trajectory someone's on, you just intervene with something, or some things, several somethings, you can see a change. Every little tick on that scale, whether it be 1 day, 1 month, 1 year, it all adds up. And so that's really, I think, where the real action is. So I am not going to stand here before you and go through all the esoteric details of artificial intelligence. First of all, my personal opinion, there's nothing artificial about it. So it's a misnomer. But it is a partner, and we have a saying, I forget who I could attribute this to, but a physician that said, physicians and care providers, their biggest fear is, oh my God, AI is going to replace me. That's not going to happen. Unless we let it, but we shouldn't, and I know we won't. But what's going to happen is AI will not replace physicians. But physicians that use AI will replace those who don't. And most of you physicians are already using AI, whether you admit it or not. It's already embedded within almost everything we do. And someone is that very, I don't want to say, oops, damn, wrong button. It's a memory test. I failed. Okay. Some of this stuff is done with just very rudimentary level AI, machine learning. We build decision support algorithms in our medical record. We try to help that provider do everything they can and not be a dementia expert, but just know that something needs to be done. Something pops up, they do this. It's a decision tree approach. If this happens, click on this, order these tests, do this, and step aside. Just know that your patient needs to have a workup, and these are the things that workup needs to include. And then the nice part about that is that we try to get them engaged in the process so that they do know that they don't have to be that expert to tell that patient, that family, what this means, because that's most of the time why they're reluctant to screen in the first place. They have many other priorities, health priorities for their patients. So once they're involved in this, and the memory team kind of takes over and does what they need to do and gets it back, then that physician can reinforce everything that needs to be said, everything that needs to be done. All of these things are part and parcel of how we take care of a patient that has a cognitive issue, no matter what end of the spectrum they're on. And education, we can't undervalue that, because education obviously it doesn't end, but we have a responsibility to everything we do. We need to translate that into something of a message that provider and that patient can have a conversation about, so that we really can do shared decision making, and we facilitate that. So we're already using this in a lot of our medical record journeys. So as far as this in healthcare for the elderly, again, we're using algorithms. I'm part of several studies where we're designing things to try to figure out how to pull things out of the medical record that would indicate that either a patient already has dementia and just hasn't been detected or diagnosed, or, more importantly, might be at risk. And it might lead to some recommendations. So we also use, obviously, predictive analytics, trying to figure out how do we profile people in a way that we're like, okay, if we want to get down to those things that we think if you intervene on these things, you're going to lower your risk, You may not completely eliminate it, but you're going to change that trajectory. That's how we do it. We pull every bit of information we possibly can. And if it's not there, then we look at that and say, how do we get that into clinical practice? How do we get these biomarkers as part of just normal practice? How do we get whole genome sequencing as part of normal practice? The information is there. It's what we do with it and how we interpret that and how we help those providers either include it or not include it in recommendations. That's our responsibility. So, and the other piece of this is being able to use enhanced visual analytics. We do a lot of user platform exercises where we get folks in, both providers, nurses, as well as patients, and we have them look at something. Because if we design something, it may look good to us, but they look at it and say, it's in the wrong place, or I don't quite understand that. I know what to do when I get to the hiking trail, but I don't know how to get to the parking lot to get to the hiking trail. So it's that upstream stuff that sometimes isn't so obvious. So being able to really refine what we have in the medical record and how that interface is used with the patient through MyChart and other things, this is so valuable. So this isn't something that we had even 5 years ago. And so we use MyChart for enrolling patients in studies, in clinical trials. We're using it a bunch. So being able to expand that use just to the patient interface so that they can be more informed about their own health, that also is very powerful. So I think there was a couple of talks already this morning talking about digital health. Who doesn't have a smartwatch and a smartphone? And, I can have a conversation and the next day my smartphone thinks that I need to know more about something I might have talked about. So it's pervasive. It's scary. We get it. But when you approach this in an elderly population, don't approach it where you think that they won't understand, or you think because they're not familiar with this kind of technology, they're not comfortable with iPads and touch screens and all this stuff. No. Approach it from the standpoint that if you give them the right information, then they can make an informed decision on whether or not they want that in their life or don't. And then that's fine. I'm okay if they say no, if it's an informed no. Many times it's just uninformed on our part. We know about the cognitive and emotional support. If you've been to the Alzheimer's conference, you see this engaging little thing called Paro. So what we know from that is that when you introduce digital technology into the home, at any level of where an elderly person is, independent of whether they have a cognitive impairment, at any level, it really can enhance their life. Many times they may really feel more comfortable talking to a robot, believe it or not, than even talking to a person. And so I have a colleague at the University of Minnesota Duluth. She has done some incredible work with robotics. And you probably read about her in New York Times or Chicago. And so she came up with this cute little robot. It comes in the room, and they're very engaging. You just want to hug the little thing. It's just so part of your life. Bright little eyes, kind of like Hollywood movies. But trying to figure out in a patient that's institutionalized, she would not brush her teeth. And it was just because there was no connection. Trying to find that connection of, I need you to do something that you know how to do, you just can't process whatever. So they've done a lot of work on this, and she came up with, the touch of music, familiar, songs and stuff. So they went through a bunch of songs. They finally hit on the one song that when you go all the way back in remote memory, what's probably one of the first songs you learned? Happy Birthday. So when the little robot starts singing Happy Birthday, this patient, it's on the video. She literally wakes up and she brushes her teeth. So it's there. Does that happen every time? No. Do we have a lot of work to do? Yes. But there's something to that. There's a signal there. So exciting. So when we think of, this is a study that came out of the group in UK. And all of these are places where we think AI obviously would provide the most benefit. You know all these. We've seen plenty of research on this. But what's interesting with this study is that they wanted to get the patient perspective. Again, getting at that big barrier. This may be the best thing for them, but if they don't use it or don't embrace it or engage it, it's not going to work. So when it came to monitoring, using it for wearables, for monitoring and diagnostics, the patient group endorsed that. They felt it would keep them better informed about their own health and also provide a safety net at home. So that's one heck of an entree. That's a start right there. And so then they also felt like, well, gee, if something bad's going to happen, I may be able to intervene early before a crisis. So they also looked at just this stratified care. And patients, we know, they get frustrated with one size fits all. This generic health and lifestyle recommendations. We need to tailor things better. But we don't want to tailor something for somebody that, we're not even sure if this would work for you. So that's where we have to do more work on that precision prevention end. We also, they looked at health and just the care system support and felt that AI would obviously automate a bunch of it just made sense to them, just like it does to us. But, if you give the patient a voice in something, that one thing is powerful, as opposed to, I'm going to tell you what you need, go do this, here's your prescription, go to the pharmacy, call me in a month. And that's not to say that every physician's not trying to do everything they possibly can, but just imagine 25 years ago, when you went to see your doctor for whatever, routine, annual physical, whatever it is, what we knew to do back then is not quite the same as what we know to do now. So these things do change. And the amount of information that you have to really make informed decisions and help that patient make those kinds of shared informative decisions to support their health, that's where AI is going to help us. Oh, you know what? I failed to disclose that I have nothing to disclose. But I would be remiss if I didn't tell you that I not only room with AI, we work together. So I do have a bit of a bias in that. My random access memory is just not as good as it used to be. But I'm 73 years old. I'm okay. It could be worse. But AI helps me. I use it on all kinds of things. Chat GPT for, I do a lot of stuff. But what I don't do is let it tell me something that I already know. But I do put it to the test. It's kind of fun. I play with it all the time. So you know what? That's not exactly right. Go check this. So it's kind of an engaging interface. Anyway, so we know that obviously even the patients can see that. Life cycle of a tool, I'm not going to go through all these things, but they did a good job of trying to figure out with the patient voice, what should this look like? What should we address? What should each step be? And certainly there needs to be an outcome. We can't build a mousetrap and then not use it. And so all of these steps are, obviously that's what you go through. If any of you are working in this area, this is exactly what we're doing right now. And I promise you that first step, getting past that first step, is huge, but it's very time consuming. But it's an investment we have to make. So looking at the precision medicine in terms of how do we preserve cognition, we have the ability to use this right now to do deep phenotyping, coupling that with all the genotyping and biological markers and everything else, so that imagine what this would look like. We need all this information in, we need to crunch all that stuff together, and we need it to fit into some things that we construct that say, if it's above a threshold, you know, it's a factor. And so the key issues here, they're not trivial by any means. When would you apply this? When would you start looking at somebody's profile? I mean, I think the sooner the better. Because if we think of biological pathways that lead to Alzheimer's disease occurring probably 10 to 20 years before we clinically see anything obvious, then if we want to close the gate before any horses get out, they don't say that up in Minnesota much. I get to use all these little colloquialisms, but you understand what that is. But preferably, we have to be even further upstream and trying to figure out when is that touch point where, as you know, when to test, who to test, be prepared to educate why you're testing, what this information is going to tell us, how we're going to use this information, why it's important for your health. All of those things are not trivial steps by any means. But then we get down to how much would this cost? And who pays? So that's, as we know, that's that trying to get over the hump of research and getting it into evidence-based practice. And many of these things are predicated on the assumption that it will eventually, hopefully, be covered. But we have to prove why that's important. You know, the ounce of prevention and all that stuff. So, again, I think the good news is there's a lot of research going on right now. I suspect many of you are already involved in many of these things about precision aging models and trying to profile people. But all of these things will apply regardless of whether we're applying it for prevention or we're applying it at any stage during that cognitive impairment spectrum. Because all of these things are designed to improve something. And we already know that even after somebody has mild cognitive impairment or early dementia, some things are able to at least slow things down, some of the interventions that we can do. So really think of this in terms of whatever we do for prevention, we need to be prepared to try to do parts of that at any stage and figure out again, well, once they have it, what works? And then once they have it more serious, what works? Again, all of that requires a bunch of data, the best data science we can throw at all of that data, and the best possible data that we have access to. So, which is certainly good that we have TARC. More on that in a little bit. So they looked at all these things, and what's important is we already know all these things. Every presentation you've seen so far, and you'll see this afternoon in the posters, every bit of research is touching on some of this stuff. So it seems daunting, I get it, that man, where do we start? And do we have to include all of this stuff? How do we do that? Well, that's where our partner called AI comes in handy. And our ability to sort out what's real, what's Memorex, what's important, what's not, what's relevant, what's tailored for this person and this group and whatever, community level, public health prevention. All of these things are not only possible, we're already doing that, just not enough of it. Just not on a big enough scale. So I think I already said all this stuff. So basically, this concept, I was so happy with, I came up with this idea of precision prevention. And I thought, oh man, I'm the first one to come up with this. So I just put in precision prevention. And of course, I got all kinds of things that I thought, yeah, that's definitely along the pathway of what you'd expect. But then I came across this NHLBI working group. NHLBI, that's kind of a high-level look at something. That's saying that we think there's something to prevention for heart and vascular. So much so that we're going to assemble a work group of, some of the who's who of heart and vascular research and informatics and others, and try to tackle this in a way that we can make progress. And the way I look at it, if they do their job, our job just got a little easier. So the take-home message here is that you already know, as an Alzheimer's researcher, you're definitely not in a silo. Everything you look at occurs in other things. Some of these markers and some of these genetic factors also put you at risk for heart and vascular and many other things. So our ability to break down those silos in a way, and I get it, most of it is driven by what's funding, what institute funds what they're looking for. But I do think that what's going to happen with this precision prevention as it really takes hold, I really feel like you're going to see more and more RFAs coming out that'll have that expectation that on your team, you have people not just Alzheimer's experts, and not just informatics, and not just whatever, truly multidisciplinary, because we know that's our field, but sometimes it's kind of hard to get into that other silo because they're busy with all of their stuff. They've got the same, tsunami coming at them with things that we should be doing a better job of preventing, we know. And so I think that the take-home message here for you guys, first of all, you're damn lucky to be here. This thing called TARC, when we started this, I promise you, we thought we might eventually have a room full of people like this. We also thought those people would be people that were using TARC data for preliminary data to be very competitive for NIH R01 type funding and program projects and U19s and everything else that comes down the pipe. You guys knocked it out of the park. And so just remember, pay it forward. Do your job, do it well, and know that a year from now, this will still be here. There may be even better things coming down the pipe. And when we talk about precision medicine, what we really need to be doing, we're talking about large sums of money. Even for the research side, we're getting up into that billion-dollar stuff. I can imagine maybe TARC, the institutions get together, very competitive, and get a multi-billion-dollar program project. What are you waiting for? Anyway, thanks. Appreciate being here. Thank you for organizing this, Monroe. Thanks to all the crew back there. I'll open it up. I'd love to hear your thoughts. Thanks. Or just eat. I think there are some microphones around if anybody has anything to say. And certainly let's continue this conversation. You know how to get a hold of me, others. Yes, ma'am. The question was how far away are we for that screening tool that goes upstream to look at those risk profiles. I'm hoping that by this time next year, if I'm lucky enough to be here someplace, we will already be talking about that. We may not have it nailed down, but this is the work we're doing right now. We're trying to figure out what are those things that really mean something. And what it's a good problem, but it's also a bad problem. What happens is science is not static. So we come up with this incredibly parsimonious model, and it just looks like, wow, we're there. This seems to explain disease in a certain percentage of folks. Then something new comes along that we couldn't even measure before, we didn't know existed, or some genetic marker that now seems to be relevant that we didn't look at before. So then we have to go back and continue to redo our models. So it's that constant refitting of what we already know that drives what we do. So when we get down to that being closer and closer, then we get to the point where diminishing returns. We don't need any more information. We already know enough to be able to recommend this be something that we put into clinical practice. Fingers crossed it'll be soon. Yeah.
Good afternoon, everybody. Thank you very much for your presentation. Omar Oropesa from South Texas Alzheimer Center and UTRGV in the border, Brownsville. I have a question. On your presentation, you asked, is the future now or coming? Now, my question to you is, AI right now is processing information that we know faster, or is creating new knowledge?
Both. If I understand your question, if you work in the AI space, you know that there's machine learning type things. We preload things and say, look for this. If it's this, it's a hippopotamus or a giraffe. But we get down to that generative, deep dive, deep learning, all of that stuff, where we give it enough information, then it starts looking elsewhere on stuff we didn't say. It brings it back. It's an iterative process. And so the future is now, and it's also near. Now, that seems kind of strange, right? Now, in my other life, I'm a musician, and I write some weird lyrics, and I like those things that don't make sense. I'm kind of like John Prine in that regard. But to your point, it's learning as we go. As we learn, it learns. So, I mean, it's not a steady state by any means, and it can't be. We have to constantly be able to say, wow, there's new information there. How does that impact what we already know? And we can't do that as fast and as probably as accurate, because sometimes that new information is in amongst gazillion bits of information and data. So we do have to have that iterative process with AI. Does that get it? Good question. And I'm glad you brought it up, because I was supposed to close with, well, you know the answer. Yes, to both. But now you know. Oh, yeah. Oh, sure. Yes, right. Good question. I don't know if you heard it, but who would benefit, and how does AI help with that processing in a clinical trial? Almost like can it predict those expectations? But I do think that that's where we get into who we put into trials and why. And so that even that, if we already have somebody that we're not preventing something, it's already there, and we're enrolling them in studies, we really do need to have a clear understanding of what's most likely going to be that set of factors that would, if this works, it would lead to some improvement. It sounds simple on paper. I know it's not. It's very complicated. But I do think that that's where yet another reason that we need to be using AI more and more, even to get people, the right people, into clinical trials. have too many failed trials, and we go back and we do. Computational biology has been around for a long time, and we've done this where we repurpose drugs and go back in and say, wow, look at all these things where, you know, we just missed something because we couldn't measure that, or we measured the wrong thing. So even the pharmaceutical world does that a lot. So, yeah, stay tuned. Back there, I think, yeah.
Hi there, Dr. Waring. Over here.
I see you.
Thank you for a fantastic talk.
Sure.
I just wanted to get your thoughts on how you perceive the recent definition of dementia being sort of more based in sort of pathology and biology versus more the syndrome at the syndrome level, and how do you think we need to, especially with AAIC's new recommendation for it to be just pathologically based, do you think we need to wait for such research to come out before we can start the classification process and integration of AI so that the model doesn't keep having to get updated so often, per se?
Right. Yeah, to your first question, I'll share a little anecdote with you. We were at the meeting in London where that was the first Alzheimer's International Conference where Cliff Jack, good friend and colleague of mine, he was presenting this biological definition. So Ron Peterson and I, also a good friend, colleague, we go out in the hallway, and I'm going, Ron, you're out of a job. Your clinical shtick is just, I'm sorry, it's not needed. So we talked about how does that impact what we're doing, and how does that change even our research questions, who we enroll in studies based on this or this. But I do think that I like, the more I talk to Cliff and, kind of read that, I like the fact that that truly is upstream, because we know that the biological process far predates the clinical process. So trying to get at that, what are all those things that really go into this diagnosis of Alzheimer's, etiologic, Lewy body, whatever it is, the more we know about that, the more we can go upstream, and that gets us into modifiable risk factors, or at least compelling evidence why somebody might be a candidate for an intervention of some sort. So from that standpoint, I think it's good for the field, because in my experience, I mean, I started at Mayo Clinic. Granted, that's a little bit different place when it comes to all the things we do for Alzheimer's research. But the clinical piece was never as definite as I thought it should be. There were too many outliers. There are too many things that we say, well, if it's this, and this, it's Alzheimer's. And then we'd do neuropath on Friday mornings. We'd do neuropaths, correlations. And, things just fell apart. So again, I mean, I do like the fact that we have a biological definition. But I think that's something that this field, this room, I think they're going to converge again. I think that biological and clinical is going to converge. It'll be a tighter convergence. It won't be, hopefully, so sometimes yes and sometimes no. So stay tuned. I hope that answered your question. Yes, sir.
Carlos from UTRGV. I was thinking about the delusion. Because here they have behavior.
I'm not understanding that. Can you?
About thank you. Sometimes the ChatGPT is making delusional responses. There is no real. They invent the responses. So even we have been working with, I am clinical epidemiologist. So trying to understand how can we use this AI in the clinical aspect. So we found that the delusion sometimes happen by asking about your experience in your research, and you find this delusional behavior from ChatGPT or Copilot as well, or Geminis in your experience? Because in mine, I found some of them. But I don't know if you, in your experience, have some delusional aspect. They don't give you the correct answer. They start to invent the answers and give you, they've been forced to give you an answer. because there is a black box anyway. They use a different algorithm, and you know how they approach, how they define the answer they are giving to you. So sometimes they become inventing. There is not real. They make fantasies.
Interesting.
Yeah. Okay.
Yeah. I have nothing else to add to that. You bet. You? Need a microphone over here.
Hello. Hi, I'm from UT Austin here, right here.
Oh, hey.
Hi, I'm a grad student
Those
here
lights are so bright, I'm sorry.
UT. So I am interested in how you think AI can help fuel like novel hypotheses into the molecular mechanisms of Alzheimer's disease, and how the next generation of like lab bench scientists should use that tool to explore new hypotheses.
Excellent question. I'm glad you asked that, because that really is another application of AI, and a very important one. Because when we get into deep learning models and all this other stuff, where it's doing more than just regurgitating what's out there. It's also trying to find connections and other things. So the more we do that, I expect it to generate whole new hypotheses. And it might be something that, wow, we need to go back to the lab and figure out, is there a marker for this? There's something that seems to be correlated. What would be that biological marker, the genetic factor, whatever it is. So I do think that too would be an expected outcome of using AI. We already use it a lot. Some journals even accept the use of AI. And in doing so, when you're using it where you know it's going to be a peer-reviewed type approach, you have to be open to the fact that it's going to tell you something you didn't know. The first thing you do is you challenge it and make sure it's not hallucinating and doing all kinds of crazy things. But what's enlightening is that it really can come up with something that you didn't think of. It's plausible. It just seems like that would be an obvious, that could happen. So is that kind of what you were thinking, or did you have a different idea?
Fine. Sorry, I'm just curious if that's an avenue we should be seeking more as a community to try to find different ways of addressing the molecular mechanisms.
Well, sure, yeah, and I think that, like I say, AI is a partner. It's not the project lead. It's not really the brains behind the project. You are. And so I think that partnership is very well suited for that type of approach if you choose it. Because I do think that we get down to a level where you see so many markers, so much genetic information, so many things coming out. Your brain's like, I wonder how much that really applies. Is that new knowledge that I need to be concerned about? Or is that some testable hypothesis I need to, pursue? Good. Happy hunting.
I had a question regarding generative AI models.
Sure.
So ChatGPT is probably the best known model now.
Sure.
And it's one that deals with text or language, right? So what do you think it would be probably the next step in generative AI within Alzheimer's that is not based on language, that's not based on text? Because there's some very interesting or exciting things with imaging and generative AI with that, but I really wanted to understand, if you have a different perspective on that, where do you think generative AI could help besides the interacting with the patient or the language manipulation in any way?
Yeah, if I understand the question, you mean in terms of just going beyond the pure text regurgitation of ChatGPT or whatever, generative AI, and getting into problem solving?
Not necessarily problem solving in a hypothetical way. Like, but what I'm saying is ChatGPT responds to language patterns, right? And
Sure, right.
the model just outputs the data based on that sphere of phenomena, just text, right? Or maybe speech.
Sure.
But where do you think it's going to be the next step? Like, what kind of generative AI that's going to help within Alzheimer's?
Yeah, I think that, first of all, when you're using generative AI, you're not just using one model, one mode. You're using a bunch.
Yeah.
And sometimes you're using geospatial information. Sometimes you're using mapping stuff. You're using all kinds of things that come from just movement and other things that are more, they're discrete, quantitative, but they wouldn't necessarily show up in the text that like the Chat GPT is looking for. So it's really just a matter of, just like we do with GIS, if you use geographic information systems, it's the ability to have all the layers of data that you need and information you need to make an assessment of what's going on and come up with a reliable estimate of truth. So I do think that it's probably more going to be just a matter of the different models come out that are really tailored specifically for visual, even graphic, whatever it is, so that too has to be overlaid with just what's in the text. And I think in many ways that gives us the ability to kind of cross-check some of that information we're getting back. Because the more layers you can test, you can say, well, that doesn't hold true over here. So then you can fine-tune that information you're getting out of that. Good question. I'm parched. I need some water. So, any more questions? I'm more than yeah, sure. Go ahead.
So, at what point is enough epidemiological research enough? Because in my experience as a startup founder and preclinical researcher, we actually know, and very recently, quite a lot about Alzheimer's disease, and I believe it's a myth that we don't know how to treat it. And so I wonder if there's a conflict between stakeholders in the clinical world, or whether there's just a lack of education, for example, on how to take the information that we do know and really focus on the bench to bedside pipeline. I guess my question being, how can we as preclinical researchers or drug developers bring clinical or clinician stakeholders sort of more into the world of the cutting edge molecular and cell biology?
Yeah, I think you touch on an issue that's not new by any means, but there is a gap between the clinical side of things that we're trying to influence and what we're trying to influence that with, and how we go about doing that. Because I can't put anything into the electronic health record as a decision support tool that hasn't withstood the test of time in a clinical setting like the one I'm putting it in. So when you put all those layers of barriers up there, it's no wonder we get anything done. And it's not that the clinicians don't want that information. It's just that they got to follow certain protocols, and if that's not appropriate to screen for cognitive, the task force came out and said, screening for we put the minicog in the annual wellness visit. Well, according to the task force, we shouldn't be doing that. But we're all about, well, how are you going to detect something early if you're not looking for it? So then I like that presentation today about the two-step, where you try to profile people and say, they're low risk. We don't need to give them the screening test. That's fine. That's one way to do it. But trying to just get over that little hump of where's the evidence that says it's a good idea to even put this into my practice when I've got 10 minutes with this patient and I've got all these other problems, especially aging patients. We collect chronic comorbidities along the way. So they've got all these other things to deal with. So it needs to be a little more precision to it than what there is sometimes of just a recommendation. Job security, though, right?
How about a round of applause for Dr. Warren? So we've got a little bit of a break to wrap up lunch. lunch and enjoy each other's company. Poster session will be at 1:30. If you look at the end of the schedule, Dr. Waring was originally going to be our last speaker, so we're going to bump things up and probably adjourn a little bit early, but stick around because we've got posters and poster judging and poster awards for Best of Show as well. So please enjoy, and we'll see you shortly at the poster session. Thank you.